we know that whatever this value is here, that the product of this probability, the probability of H, times the probability of A under independence should give me the probability of H and A. Well, H and A is 11%. And I know that the probability of A is 24%. So that only leaves me with figuring out what the probability of H is. Well, this is just a variable right now, so if I divide both sides by 0.24, I get 0.11 divided by 0.24 is 0.458. So the probability of H is about 0.458. And that's how we could still use this formula to help us figure out components that we're missing. One often complex idea is this one here. So suppose that each day you find that there's a 58% probability that you are part of a traffic jam on the I-10. That's here in Arizona. Thus, 42% of the time the road is free and clear. What is the probability that you're part of a traffic jam at least once during October? 31 days long. A good starting place would be to think about the sample space. So what are the possibilities? Well, we want to know the probability of having at least one traffic jam. Well, since there are 31 days, if we begin to think about this sample space, so here are my set of possible outcomes. Well, what can happen over these days? Well, yes, it either is a traffic jam or it is not. So my sample space is, okay, well, I get stuck in traffic 0 out of the 32 days. And so that means I'm free and clear, so not stuck 32 times. Well, I could also get stuck once and not stuck the other 31 days in a traffic jam. I could get stuck twice. I could not get stuck 30 times. Well, this type of pattern continues up to me potentially being stuck all 32 days in a traffic jam and not stuck none of those days. So basically I'm experiencing a traffic jam every single day. Well, I want to know what's the probability of getting in at least one. So as we know, that means one or more. Well, that's a hard thing to come by because, well, if you look at getting stuck in one traffic jam just one out of those days, that could be on any one of the 31 days. So I've got to take that into account. Okay, well, I know that the probability I get stuck is going to be 0.58. That means the probability that I won't get stuck, I'll use this notation, so this really means not stuck. I get not stuck 42% of the time. Well, assuming that we have independence here, that getting stuck one day does not affect me getting stuck the other day. Now, we have to make that assumption or else we can't really make a calculation. So I want to figure out the probability of getting, so if we do one or more, we would have to do all these individual scenarios. But the probability of any one of these things happening, this accounts for 100% of all possibilities. Okay, well that must mean that if I can figure out what this is, and I take it away from 100%, that leaves me with what I'm searching for. So what I'm going to do is I'm going to get rid of this outcome here. I'm going to get rid of this, but first I need to find out the probability of it. And that's pretty easy to find. So I want to find the probability of getting not stuck, and not stuck, and not stuck, and ... not stuck 31 times. I think I was using 32 up here. So 31, 30, this would be 29, and this would be 31. So there are 31 days in that month. So that is really just the probability of not getting stuck times the probability of not getting stuck times the, well, you get the idea. So the probability of not getting stuck is 0.42. Well, I'm going to be multiplying 0.42 by 0.42 by 0.42. I'm going to be doing this 31 times. So 0.42 to the 31 is almost 0. So that means almost 100% of the time I'm not going to get stuck. 1 minus